Good morning, ninth grade extended students. Today we are going to be continuing with triangle proofs. I'm going to give you a few more reasons that you can use in your reason column, and you will have time to practice. Just to review, statements are specific, reasons are general. In your reasons column, you may use theorems, postulates, definitions, given, and now I'm going to let you use a reason that's called assume from diagram. Assume from diagram can be used in a very limited number of cases. You can assume straight angles from a diagram. You can also assume angles from a linear pair of supplementary angles. And of course, the theorems that you use have to be theorems that we have covered in class to this point. Here are some more properties that can be used in your proofs going forward. The first is the segment addition property. This basically says if I have equal segments that I'm adding together, then the whole pieces of the segment are congruent as well. So here's an example. If AB is congruent to EF and BC is congruent to DE, then the entirety of the segments are congruent. Then AC is congruent to DF. That's the segment addition property. Segment subtraction can be also used if you have whole segments that are congruent and a part of them that's also congruent. You know what remains will be congruent as well. So here's an example. If AC is congruent to DF, this entire segment congruent to this entire segment, and AB is congruent to EF, then you would know that BC, what remains, is congruent to DE. This also works for angles. So angle addition would say if I have two pieces of angle, then the whole angle combined has to be congruent. So here's an example. If angle 1 is congruent to angle 3 and angle 2 is congruent to angle 4, then I know that angle ABC is congruent to angle DEF. I can also subtract. So if I know the larger angles are congruent and a piece of those angles are also congruent, what remains will be congruent. So if I know that ABC is congruent to DEF, and then I know angle 1 is congruent to angle 3, I could conclude that angle 2 is congruent to angle 4, and the reason there would be angle subtraction. Same kind of thing happens with division and multiplication. So if I have a segment that's cut in half, and I know the entire segment is congruent to another entire segment, if they're both cut in half, the pieces are congruent as well. So if B is the midpoint of AC and E is the midpoint of DF, and AC is congruent to DF, the entirety of the segments are congruent, then I would know that the pieces are congruent. AB is congruent to DE. AB, DE. Likewise, I could also conclude that BC is congruent to EF. Regardless, the reason there is segment division. Segment multiplication works the opposite way. If I know that I have two segments that have been cut in half and I have one of the pieces, then I know the entire segment must be congruent to the other entire segment. So I still am given that B is the midpoint of AC and E is the midpoint of DF. This time, though, I'm told that the pieces are equal. I know that AB is equal to DE. When that's the case, then I know the whole segments must be congruent. AC is congruent to DF, segment multiplication. That's another reason that you can use in your proofs. Just like segment addition and segment subtraction also work for angles, division and multiplication also works for angles. So if I know that BD bisects angle ABC and FG bisects angle EFH, and I know the entire angles are congruent, then I know the pieces are congruent. Division. Entire angle, cut in half, divide by 2, 1 is congruent to 3. I could also conclude that 2 is congruent to 4. Likewise, multiplication works as well. If I know that BD bisects angle ABC and FG bisects angle EFH, and I further know that one of the pieces is congruent to the other, one's congruent to 3, I can conclude that the entire angles are congruent. Here are a few more theorems to add to your toolbox. All radii are congruent. All right angles are congruent. If two sets of angles are congruent in two triangles, then the third set are congruent. Congruent supplements theorem. We've been using this, I just haven't called it that. Angles are congruent if and only if they are supplementary to the same angle or congruent angles. Congruent supplements theorem says angles are congruent if and only if they are complementary to the same angle. So let's go back to this a minute. Radii are congruent. That should be obvious. I'm looking at a circle. If I know the length of AB, I know that the length of AC is the same. And the reason is all radii are congruent. All right angles are congruent. Obviously, if I have two right angles, clearly they must be congruent. The next one says if two sets of angles are congruent in two triangles, then the third sets are congruent. Okay, if I have two triangles and I know this set is congruent to this angle is congruent to that, this angle is congruent to this, then clearly because angles inside a triangle sum to 180, the third sets must be congruent as well. And the congruent supplements theorem, we have been using it. If I have two angles that are supplementary to the same angle, if I know 1 is supplementary to 3 and 2 is supplementary to 3, then I know that 1 is congruent to 2. Okay, and it works the same way for complementary. So has to be true. If this is 120 and I know that angle 1 supplementary to angle 3, that means that angle 1 is 60. If I know angle 2 is also supplementary to angle 3, that means angle 2 is 60. Therefore, they are congruent to each other. So, the worksheet that you had homework on Friday, I did not assign all of it. We're going to work on example number 4 together. Then I'm going to give you time to practice one, you can see the answer, and then you can practice on the remaining problems that I've posted in the assignment. So the first thing that I'd like to do every time I see a proof is mark down what I know. I know that BD is congruent to CE. BD is congruent to CE. I know that angle FBC is congruent to angle FED. I know that angle FCD is congruent to angle FDC. And I'd like to prove that triangle BFC is congruent to triangle EFD. Remember, anytime you want to prove triangles congruent, you basically need to find 3 congruent pieces from each of them, sides or angles. So let's take a look a little bit closer at this. I'm looking at this small sliver on the left and the small sliver on the right. Notice this angle is congruent to that angle. All right. Well, angle CBCF here is supplementary to angle FCD, and angle FDC is congruent to FDE. That congruent supplements theorem would allow me to show that this angle must be congruent to that angle. All right, well, that's good news. Okay, then I have some choices. I could use segment subtraction to get this segment equal to that segment. Then I have angle, side, angle. Or I could look at this inside triangle and see the congruent base angles and know this side is congruent to that side. And then I could use angle, angle, side. I think I'm going to use segment subtraction just so you can see how that works. But again, there's lots of ways to do proofs correctly. So let's start. All right, I know that BD is congruent to CE. While that's nice information to have, it's not one of the sides of the triangles that I'd like to prove congruent. So I cannot put an S out in the margin. But again, this is given information. So that is my reason there. And what I'd like to do with that is show that these little pieces on the outside then must be congruent by subtracting the segment CD. So I know that CD is congruent to itself, and I know that because of the reflexive property. And now I can say that BC is congruent to DE. And that is segment subtraction. Okay. Now I'm looking at angle, side, angle. So I have my side from the angle, side, angle. I now have to have two sets of angles. So let's see what we have here. FBC, this guy, is congruent to angle FED, that guy. Oh, that is the angle just on its own. So I'm going to write that down. Angle FBC is congruent to angle FED. That's given. And that is one of the statements I need to prove the triangle is congruent. The next angle that I was given was FCD and FDC. All right, well, that's not inside those triangles, but I do need it. So let's see. FCD is congruent to FDC. That's given. And now remember, the whole idea was that I'd like to say that this angle here is congruent to this angle there. And we're going to do that with the congruent supplements theorem. So I first have to say that FCB and FCD are supplementary. And then I have to say that FDC and FDE are supplementary. And remember, at the beginning of this lesson, I told you could say assume from diagram on that. So let's go for it. Angle FCB and angle FCD are supplementary. Assume from diagram. And let's see, angle FDC and angle FDE are supplementary. That's also assumed from diagram. But the good news is, now that I've said that they are both supplementary to congruent angles, then I know they're congruent to each other. So, angle FCB is congruent to angle FDE. That's the congruent supplements theorem. And that is the last thing I need to do to show those triangles are congruent. So now that I have that, I can say triangle BFC is congruent to triangle EFD. And my reason is angle, side, angle. 4, 3, 8. The 4 and the 8 can change places, but the 3 needs to be in the middle because that's the set of sides that I indicated that were congruent. Here's one for you to try out. You'll note that we are not trying to prove triangles congruent, we're trying to prove segments congruent, which is going to indicate that you will need CPCTC in here somewhere, somehow. You're going to choose to prove triangles congruent, and then their parts are congruent. So press pause on your video, give it a try. When you're ready, press play again. Here's my answer. So again, like I said before, I like to mark what's given first. I know that NW is congruent to SW. I also know that angle MNS, this whole angle, is congruent to angle TSN, this whole angle. I'd like to prove that MN is congruent to TS. One thing that can be hard to do when you have overlapping triangles is pick which triangles are going to be helpful in making what you're trying to prove possible. So looking at this, I can see that I want to show that MN is congruent to TS. That's part of this little triangle here. It's also part of this larger triangle there. Same thing with this guy. It's not really possible to go with the larger triangles because I'm not given this entire segment length here. I'm not given that entire segment length there. I'm just giving pieces of them. I would have to know something about these little pieces of sides there. So I'm going to work to show this triangle here is congruent to that, and then I'll be able to conclude that this side is congruent to that side through CPCTC. So, starting with NW congruent to WS, that's given. Now, because I know that these sides are congruent, this is an isosceles triangle, and that's going to allow me to conclude that angle 3 is congruent to angle 4. So that's my next step, and that's my reason. If isosceles, then congruent base angles. All right, well, now I have things set up very, very well, because if I know these are congruent, I can get to these angles being congruent through angle subtraction. So I state that MNS is congruent to angle TSN, that's given. And now I'm set up to subtract. So I subtract angle 3 and angle 4 from these angles. That gives me angle MNW here and angle TSW here. And I am all set for having a set of angles that are congruent in order to prove that my triangles are congruent. So that's these guys. And I actually have a set of sides already. That was in my given statement. So now I have a set of angles, I have a set of sides, and I need one more thing. Well, angle 1 and angle 2 are vertical angles. So since those are vertical angles, I know they're congruent. So my reason here should be vertical angles are congruent. And I like it if, then. So if vertical angles, then they are congruent. And now I have all the pieces of information that I need. So I can say triangle MNW is congruent to triangle TSW by angle side, and that is 4 angle 5 angle 1 side. Now that I have that, I can conclude that the corresponding parts are congruent. MN is congruent to TS, CPCTC. Now, the way to get good at writing proofs is by practicing, and I have lots of opportunities for you in the worksheet that I've assigned. We will talk soon.